Right, question 2. We've got the monthly income for workers in a factory here. Okay, I've got to calculate the 34 to 66% into percentile range. Right. Let's first of all establish how many workers we are dealing with here. So if I add up those frequencies, I see that n is 70. So the 34th centile, that is going to be 34% of the 70. It is going to be the 23rd.8th person. All right. Let's have a think about their monthly income, assuming, of course, that the monthly income of each of the workers is evenly distributed across each class. So the 33.8th is going to be in this class here. The first 3 are dealt with already, so that takes me up to 1,000. And then I'm going to have 20.8 more to go. So I'm going to need to have 20.8 out of the 24 in that range. I'm going to go that far along, and the class width is 100. So that gives me a monthly income for the 23rd.8th person of 1,086.6 recurring, so let's say 0.7. All right, let's have a think now about the 66th centile. So let's find out which person that's going to be. Well, 66% of 70, I'm looking this time for the 46th, the 46.2th person. All right, so let's see where they're going to be. That's the first 27 people there. Now the 46.2th person is going to lie somewhere here. Right, so we know their salary is going to be 1,100 plus a certain fraction of this extra 100. Right, well, we've already dealt with 27 people. So how many people are going to need to go into this range for? Right, well, that's going to be 46.2 minus the 27. Okay, over what's that class? What's how many people in that class? 28. So I'm going to go that fraction of the way between 1,100 and 1,200. And so the class width is 100 there, so I'm going to add on that fraction of 100. So that gives me a salary for the 46.2th person of 1168.57 and so on. So the 34% to 66% interpercentile range is going to be 1168.57 and so on. Subtract 1086.7 or 0.6 recurring, which gives me an answer of 81.90 and so on. So I have said 81.9 for my answer. Okay. Part B. Estimate the number of data values that fall within this range. Well, if I've got from 30 to 34% all the way up to 66%, then I'm obviously within that range got 66 minus 34, I've got 32% of the people. Well, there were 70 people. So 32% of 70 is 22.4. So how many people do I estimate fall in that range? 22 people. And that is question 2 done. Question 3. Right, we've got a train travelling from Lancaster to Preston, and the times to the nearest minute it took for the journey are recorded over a certain period. The times are shown in the table. Now be careful. These are times to the nearest minute. So where, for example, does this class width start? Answer, it starts at 14.5 minutes. Okay, and in the same way, that is 16.5, the end of one class width and the beginning of the other. So these class widths here have a width of 2. You might be mistaken and think they have a width of 1, but they have a width of 2. And importantly, they start at 16.5, 18.5, 20.5, and this one ends at 22.5. So beware. Okay, all right, let's get on with the questions. Calculate the 5% to 95% interpercentile range. All right, how many trains are there to the nearest minute it took? Well, what do these frequencies add up to here? There are 60 trains on the table. Right, so the 5%, well, 5% of 60, we're interested in the third train. How late was the third train? Well, it's in this first interval, okay, which starts at 14.5 seconds, and it is going to be 3/5 along the way of that interval, and the interval is 2 minutes long. So that third train, assuming these 5 trains are equally distributed in that class, the journey time is 15.7. Right, what about the 95th one? Sorry, the 95th centile one. 95% of 60, we're looking for the 57th train this time. Right, which class is the 57th train going to be in? Answer, it's going to be somewhere here, isn't it? It's going to be amongst those 10. Okay, so that time there is 20.5. Of course, it's not at the beginning of that class, is it? It's 7/10 into that class, and the class is 2 minutes wide. So the time for that train is going to be 21.9. So the interpercentile range there is going to be 21.9 minus 15.7, 6.2 minutes. Okay. Part B, estimate the number of data values that fall within this range. Well, the range is from 5% to 95%. So the range is 90% wide, and 90% of my 60, what are they? Trains, whatever they are, is 54. So my estimate is that 54 data values fall within that range. And that is question 3 done. Question 4. Right, from the large data set, the daily mean temperature of Leeming during the first 10 days of June 1987 is given below. There they all are. Part A, calculate the median and interquartile range. Right, well, I'm going to need to have them in order, aren't I, these 10 days, if I'm going to calculate or find the median and the interquartile range. There are only 10 of them, so I'm going to write them out in order. Just don't get it wrong. I've already worked it out, so I'm just copying down my 10 temperatures from lowest to highest. 12.7, 13.2, and 14.3. Just check 2, 4, 6, 8, 10. Yes, I've got all 10 there. Right, now the median. Well, the median is going to be the halfway one. I've got an even number, so it's going to be halfway between 10.9 and 12.1. So the median is going to be 10.9 plus 12.1 divided by 2 gives me a median of 11.5. Right, the interquartile range. Well, it's going to be the upper quartile minus the lower quartile. Okay, so The upper quartile is 12.7, and the lower quartile is 10.3. Okay, so 12.7 minus 10.3 gives me an interquartile range of 2.4 in June. Okay, part B. The median, oh, now this is June, so let's just make it really clear that that's June, because part B relates to a different month. Part B tells me the median daily temperature for Leeming during the first 10 days of May. Okay, so in May, let's have a look. In May, the median was 9.9, and the interquartile range was 3.9. Whereas I've just worked out, haven't I, that in June, the median was 11.5 and the interquartile range was 2.4. Okay, compare the data for May with the data for June. Right, so let's look at the medians first of all. I see the median is higher in June than it is in May. So in my answer, I need to say the bleeding obvious, the median in June is higher than the median in May, but I need to also say what that means. So I'm going to say that on average, the temperature was higher in June than in May. That's interpreting the differences. That's interpreting the fact that the median is higher in June. So I'm going to say as the median in June was higher. So I'm going to explain how it is I reached that conclusion. Now, what conclusion can I reach looking at those interquartile ranges? Well, the interquartile range is higher in May, isn't it? So in May, what does that mean? It's got a higher interquartile range. It means the temperature is more variable. The temperature was more variable. Now, I better explain why than in June, and I better explain why as the interquartile range in May was higher. Okay, there you go. Full marks for part B. Right, part C. The 10% to 90% intercentile range of the daily mean temperature for Leeming during July was 5.4%. Right, C. So in C, we're talking about July, and it tells me that 10% to 90%, the interpercentile range there was 5.4. Okay. Estimate the number of days in July on which the daily mean temperature fell within that range. Well, that's a spread there from 10% to 90%. That's 80% of the days are going to lie in between there, right? So 80% of the days in July. How many days in July? 31. So 80% of 31 days will fall in that. 80% of 31 is 24.8. So I estimate that 24 days will lie in that range. And that is my answer for C, for part C, and that's question 4 complete.